Hello everyone and welcome back to this series where we're building and optimizing RAG workflows with LangGraph. So far we have had an introduction to RAG. We built a simple RAG workflow, and in terms of optimizations we looked at query optimization specifically, and we looked at a few techniques here, right? Now we'll move on from query optimization to a different component. But before that, if you haven't watched these videos already, I would encourage you to check them out first. With that, let's dive into today's video. So let's take a quick look at the components, right? We have sort of four moving parts here: query, your vector base or the vector store where we get the context from, the prompt, and finally the generation, right? So when you want to optimize it, you'll obviously have to look at each of these moving parts or each of these components and find ways to optimize them. So far we looked at the query aspect, right? The user query. Now let's move on to the vector store or the actual context itself, right? So the technique we'll learn or look into today is called as CCH, or something called as Contextual Chunk Headers. Right now, let's see what happens at the time of chunking. So let's say we have, oops, why is it so big? Yeah, so let's say we have this document, right? Big document. Let's say it's something about LLM, and it starts with some definitions about LLM, its function, so on, and maybe how to train an LLM, the various stages, and so on. So now this document we chunk it, right? So let's say this ends up as 3 different chunks. Naturally, what happens is, when you begin a paragraph, right, you have more understanding of what the topic is, because that's how the documents are written and so on. But as you progress toward to the consequent paragraphs or the sentences, you start referring to the actual subject in a third person, right? Like, say you start using words like it, they, them, and so on. So if you are just seeing this particular document, you may not have much context of what we are trying to say here, right? If I were to well, you might understand if you actually study the document, but the way the retrieval happens is we're looking at similarity scores, right? So if I were to ask what is an LLM, maybe this document might not be a good match, simply because there was no good usage of the word LLM here, right? And so on for the other documents as well. And also, as you progress through, right, let's say we're discussing about some the various stages of training an LLM. Maybe it starts with stages 1, 2, and here somewhere it's sort of broken down between stages 3 and 4, right? There's no clear line written where it says these are the stages of LLM. So when I pass in a user query stating, hey, what are the stages of an LLM, there's a good chance this chunk never gets picked up, because there is no proper keywords present here, right? So the problem is, we have our chunks, right, and but there's not a good indicator or good description of what this chunk is about, and that's where this technique comes in. So what happens is, for each of the chunk, right, we'll use a different, right? So let's say for each of these chunks we have this chunk, right, chunk 2, and so on, 3 third chunks so far, so on. For each of the chunk, we'll pass it through an LLM, right, and create a small description or like a title for each of them, right? So the LLM will go through this chunk, and it will create a title for it. You can also create like a short summary for this, right? So what happens is, oops, can I move this here? Yeah, okay, never mind, never mind, messing it up. So yeah, so what I'm trying to say is, for each chunk, we can create a title as well as a short description, which when then embedded, right, will give more context as to what this chunk is all about, right? Now An obvious disadvantage to this is that you are increasing your token size. So let's say here we broke it down into 400, oh no, I think 1000, right? We broke it down into 1000 tokens each. Now this is going to be an addition of another, I don't know, 15, 20 tokens, another 100, 150 tokens here. So this is an increase in the token usage, but I think the idea we're trying to study here is enriching your context. So this is your context here, the chunk is the context here. We're enriching it with some headers, right? And the header here is can be your title, like a description, and your summary, right? So this in essence is what contextual chunk headers is. Now let's go to our VS Code and yeah, basically see how this is written in code. Again, you start with your libraries, load your libraries. The key aspect here is indexing with CCH. That's the main aspect here. So if you have watched the previous video, even in hype, that was like the main aspect here. So at the time of chunking, we pass each chunk to an LLM and create a title and a description for it, which then gets appended to your original chunk, right? Which is then embedded, right? So normally you would just chunk and embed, but here you chunk, add your headers and like the contextual headers to this chunk, and then embed the chunks, right? All this remains the same. You define in your embeddings, you specify a path, and you specify an LLM, and the prompt here says you are a document analysis assistant. Given the following text chunk from a document, generate a short descriptive title, maximum 10 words, a 1 to 2 sentence summary of what this chunk is about, and respond is in this exact format, right? And we have a function definition here. You simply load the file. We are still using this PDF about LLM, and we're just using the first 16 pages, right? So you're loading this. We are using the PyPDF loader to load the documents, and finally you load these documents into docs. We're using recursive character text splitter with chunk size 1000 and overlap 200 to split, and you're using this text splitter to split the documents on this docs, right? Now each of this docs has your chunks, so you're accessing each chunk within this chunks, and formatting it with this prompt and invoking it to with this LLM, right? And this the output, or like the responses content, is actually your header, right? And your enriched content is basically your header with your original page content. So your enriched chunks will be simply an append. Will simply append this enriched content, and this is of the type document, right? And of course you are storing the metadata as such. Finally, we are using Fez to create the embeddings, and storing it into the vector store, and it is stored in your local, right? So the first time you run this, it will call this function, but henceforth, since this file is already existing, it will simply load it from your local, right? So this function works only once, and after this it's pretty much the same. You define your LLM, define your state variables, and the prompts for your RAG. You have 3 nodes here: retrieval, augment, and generation. All of this is pretty much the same, right? So at the time of retrieval, you will retrieve your context with chunk headers, or like your enriched version, but otherwise it's literally the same. These enriched context or contextual chunks are then augmented with your original query, and then the generation happens, right? And yeah, that's pretty much it. Now, like always, let's test it with an example. So the question I'm asking here is, what are the steps involved in training a language model? I'll also pass this question to our basic RAG, simply for comparison as to how a basic RAG would do and how a optimized version of this will work, right? Let's run the first basic RAG for time being. Meanwhile, I'm going to copy the file name and also run this, right? So the first variant is going to run. It is taking a lot of time, I guess. Yeah, we've got the answer. So the question was, what are the steps involved in training a language model? It says, hey, data preparation, language, LLM architecture, training loop, load pre-training weights, and so on. Fine. And our second, or like the optimized version, has also produced an output. Yeah, here it says 4 steps, but yeah, nonetheless, we got our outputs. Let's go to LangSmith now, which is a tracing tool from LangGraph or like LangChain community themselves. And let's trace the output. Yeah, so this was our basic RAG, right? Now let's leave this for time being. Let's see the optimized version and how things have worked here. So we want to see the documents, right? Yeah. So LLM to create a classification model, fine tunes our pre-trained LLMs. Yeah, we've got some stages here: stage 2, stage 3, stage 1 as well. Yeah. So what happens is, this was the original chunk, which was passed on to an LLM, and it created a title and summary. Let's see how uh, stages of developing a language model. The text outlines the 3 main stages in coding a language model, which includes implementing the architecture, pre-training the model, and fine-tuning. Yeah. So our question little said, what are the steps involved in training a language model, and the summary also included this line. So maybe because of this, it was able to draw a higher similarity score, and hence it picked up this document. Let's see some more examples. um, there are some definition here. Of course, I don't know this PDF, how things are structured, so I'm only seeing the examples new. Yeah, so again here, the process of creating language models, emphasizing the importance of pre-training. Again, this has discussed a different aspect of the stages in training. We have our pre-training and fine-tuning here. Yeah, so in a sense, it has added additional context to our original chunk. I think one more thing we can do is actually add a header called a chunk here, instead of just pasting things here. But yeah, okay. Again, some stages, these are the keywords that's being repeatedly picked up. Yeah, I think I'm happy with the answer. But more importantly, we want to look at how the things work internally, right? And not necessarily the answer for time being, because what can work with one question may not necessarily work for the other. There's a good possibility that the basic RAG ends up picking up the right answer, right? The goal here is to see how different techniques can be implemented with our RAG workflows, and not necessarily to find the optimized answer, right? With that, let's go to our basic RAG. Let's see what the documents this was able to retrieve. I think we saw this document earlier as well. Understanding language models. Let's see. To create classification. Yeah, this was another document that it picked up. Yeah, I think in essence, these are literally the same. Maybe this wasn't quite there. The other 3 documents were there. Yeah, so I would say in this case, both basic and your contextual RAG worked well, because even within your actual chunk, the word usage were quite consistent. So you didn't necessarily need a title or a description in this case. But let's do one thing, right? Let's take, I have like a, where did I put it? A similarity score comparison. So it basically uses sklearn's cosine similarity to find the similarity between the two sort of sentences. So our query in this case was this, right? Is this copying? Yeah. What are the steps involved in training a language model? Now this, can I copy this somewhere? No. Yeah, so let's copy this entire thing. So this will be your CCH racks text. Your basic rag will be the same but without the title or the description. And now let's try to see the similarity score between your query and your basic rag, and between your query and your CCH rag, right? I hope this runs and I don't have to install any dependency. This and then this. So we should ideally see a higher similarity score for the second one. Let's give it some time. Is it still running this? Yeah. So as we can see, the basic rag similarity score had 0.16 and this had a score of 0.23. Now although the eventual answer or the eventual documents that were retrieved, the documents retrieved were literally the same except one, I guess. The output were more or less the same. I haven't of course gone into detail in studying them, but I think it has got the essence of it. But I think we can understand the point here, right, with the similarity score, that when you use something like a CCH to add context to your basic the original chunk, it is able to draw a higher similarity score and hence pick up the documents. Like I said, in this case maybe wasn't a very good example, but definitely a technique that you should know for using in your specific use cases. So I think with that, let's conclude this video. This is the first video in of course not the first video in the series, but first video in this sort of category where we are focusing on optimizing the context, the vector that's stored. Next video will maybe look at another technique in this very category. Yeah, do let me know how you're finding the series. Drop your comments if you have any question, and I'm also active on LinkedIn, so do reach out if you have any questions and I'm more than happy to help. With that, let's see in the next video. Thank you, and yeah.